Hi everyone, today we are going to talk about how you can find the product of two single terms. And also we'll be reviewing some work with exponents. Okay, let's start off with this example. In this example, they want us to find each of the following products. And these problems show us two different single terms that are being multiplied together. So we don't see a multiplication sign between them, but we know that parentheses basically indicate multiplication. So we need to find the product between these single terms. And what we mean by single terms is that each of these is like a term in an algebraic expression. Okay? So in order to do this, for A, they want us to find the product of AB times B squared times C. What we can do is we can first expand them out. AB is really A times B, and again, this is multiplication between them. And B squared is really B times B times another C. Okay, so what we're going to do at the end is just simplify this down to one algebraic expression that is the product of those two single terms multiplied together. So in total, I now have an A being multiplied by 1, 2, 3 B's. So B times B times B, if you remember with your exponents, basically can be rewritten as B cubed, and then you multiply by a C as well. So at the end, you get AB cubed C, or A times B cubed times C. We like to write them in alphabetical order, so be sure that you're doing that. And we don't need the dot or the multiplication sign in between them, because in algebra, that just gets a little confusing with the dot and the X. Okay? For the next one, we're going to do the same thing. So I'm actually going to write my coefficients, my 3 and my 5, in the beginning here so that I have them grouped together. And then I have x squared, so that's x times another x. And I'm going to group this other x squared together as well, because remember at the end I want them all in order, so I'm just going to do that already. And then I have a y for the first term and a y cubed for the second term. So I should have 3 y's from the second term. Okay, 3 times 5, both my coefficients written in the front because I want it to end up in the front later on. X squared and another x squared, so in total 4 x's. And then a normal y being multiplied as well as 3 extra y's because it's a y cubed. At the end, I will get 3 times 5, which is 15. 1, 2, 3, 4 x's, so x to the 4th power. And 1, 2, 3, 4 y's as well. So at the end, my final answer is 15x to the 4th power times y to the 4th power. Okay, so I basically multiplied those together, but made sure I rearranged my coefficients and my variables so that they are in order and written in this particular format. All right, you're probably thinking to yourself, but there's got to be an easier way, right? Instead of expanding it all out. And that's true, there is an easier way. So this is when we want to talk about your shortcuts, okay? So instead of expanding it all out, you can take a look at, let's say, A, for instance, and you'll notice, well, they only had one A in the beginning, so that one A ends up over here. But instead of expanding out the B variables, you can look and see that this B right here is B to the 1st power, right? Because there isn't a power. So technically it's B to the 1st power because there's only one B. Here it's B to the 2nd power. What's the shortcut here? Well, instead of expanding it all out, you can say that B times B to the, actually let me put the dot there so it doesn't get confusing. B to the 1st power times B to the 2nd power is really B to the 1 plus 2, or B to the 3rd power. So really all you do when you're multiplying variables or numbers with the same base is that you're adding their powers together, because at the end when we're multiplying them, we're just counting in total later on how many b's there are, right? And then again, the c, there's only one c, so in your answer there's only one c as well. Okay, so we're really adding. Let's check and make sure that this trick works in the second problem. Switch to a different color. So here we have x squared, and then here we have another x squared. So remember, when we multiply with the same base, we're really adding their powers together. So this is x to the 2 plus 2, or x to the 4th power. Is that what we got at the end? Yes. Okay, let's check the y's. I had a normal y, so that's to the 1st power, multiplied by y to the 3rd power. And so we know now that we can just add those together. So this is really y to the 4th power. Okay, so instead of expanding it all out and then regrouping it again, you can just add your powers together. That's if they're being multiplied together. Okay, the trick here is that if you do have coefficients like normal numbers, you just do normal multiplication there. 3 times 5 is 15. Do not add 3 plus 5 to get 8, because there's no addition going on here. This is all multiplication. The addition is the shortcut for when we have the same base being multiplied together and you're adding the powers. Okay, so let's make sure you write something in your notes, okay? That the shortcut for, let's say, x to the a power times x to the b power is that you're just adding whatever those two numbers are together from your powers, and you're keeping the variable, okay? So a and b here are just representing whatever power you have that's in that problem. You're adding them together. That's the shortcut. All right, let's have you work on this problem then. Go ahead and pause your video and try this on your own. You can expand it out, or if you feel like trying out the shortcut, do that. All right, so let's try A. A is, let's expand it out and then, or actually let's try the shortcut and then we'll expand it out to try and see if it matches, okay? So this is p to the 1st power, and then there's only that one p. And then q goes next in alphabetical order. We have a 2nd power, plus this is to the 1st power. Okay, remember we're adding because that's a shortcut. And then r is to the 4th power, there's no other r's. So at the end we get p, a normal p, times q to the 3rd power times r to the 4th power. That should be our final answer. That's using the shortcuts. Let's go ahead and expand it out and see if that shortcut really worked. So if we have p times q squared, we'd have p times q times q times qr to the 4th power, so we multiply by another q, times r times r times r times r, because it's r to the 4th power. Did our shortcut actually work? Well, we do have one p. We have 3 of the q's, and we have 4 of the r's. So indeed, p times q cubed times r to the 4th power is our correct answer. Okay, let's look at B. Let's use our shortcut. So according to the shortcut, let's go ahead and put our coefficients together. 2 times 7. And then we have m, because we're going in alphabetical order, to the 2nd power plus the 3rd power, because our shortcut is to add, times n. This doesn't have a power, so it's really a 1, plus another 1. Okay, so be careful there. If there's no power, the power is 1, not 0. So according to our shortcut, 2 times 7 is 14. Times m to the 5th power, because 2 plus 3 is 5, times n to the second power because 1 plus 1 is 2. Okay, that's our answer. Let's expand that problem to check it. 2 times 7, I'm going to group together my coefficients. Then I'm going to put my m's together. I have 2 m's from the first term. I have 3 m's from my second term. 1, 2, 3. And then I have 2 more n's, 1 from each term. Okay, 2 times 7 is indeed 14. I have, how many m's? 1, 2, 3, 4, 5. 5 m's. And I have 2 n's. Okay, so did our shortcut work? Yes. So use whichever one you feel more comfortable with, but they both should get you the same answer.